Okay, so I'm looking at last Thursday's class, looking at this modified paper. The first part of this question 6 says sketch two circles that are touching externally. So sketching two circles, I'm not going to be very accurately, it just says sketch. I'll do my best circle drawing. Those two circles touch externally as long as they have only one point in common and no interior points in common. You see, it's not really circles. It's not great. My artistry is not brilliant, but those are two circles that are touching externally. If they were touching internally, one would be completely contained within the other. They would also share points. It says also show that circle C, x squared plus y squared plus 4x, subtract 2y, subtract 95 equals 0, and s, x minus 7 squared plus y minus 13 squared equals 25. Show that they touch externally. Okay, so one thing to note about externally touching circles is they have a common tangent line which is perpendicular to each radius. So the distance from the center of circle C to circle S should be the same as the sum of their radii. That's how we prove circles are touching externally. So the distance between their centers is equal to the sum of their radii. So the first thing we have to do is find the center and radius of each. I might just start with S, the center of S. It's fairly easy to spot. It's the opposite of negative 7, comma the opposite of negative 13. And the radius of S is going to be equal to root 25, which is 5. Okay. And circle C, depending on what you want to know, there is a formula for figuring this out. You could complete the square and express it in center radius form, and then work from there. Or if you know the formula, you can do it. Maybe I'll do the first method. We'll take circle C, and I'm going to rewrite that in center radius form. So grouping my x terms together, x squared plus 4x, leaving a gap to complete the square. My y squared minus 2y, leaving a gap to complete the square. I'm going to shift my negative 95 over to the right, and I'm going to complete the square. So hopefully at this stage you know that I add in the square of half the coefficient of x here, which would be 2, and over here I add in the square of half the coefficient of y, which would be negative 1. Also, if we're adding those things on the left, we need to add them on the right in order to keep the whole thing in balance. The square of negative 1 is just the same as the square of 1, so I'll just write it like that. And then I can rewrite the circle C as x plus 2 all squared plus y minus 1 all squared equals 95 plus 4 plus 1, that's 100. Okay, and you can see hopefully that the center there of circle C is going to be equal to negative 2 comma 1, and the radius of circle C will be root 100, which is 10. Okay, I want to show they touch externally. So I'm going to start off by saying that C, circle C, and S will touch externally. And this is, we went through this last year. You need to know this kind of statement by heart. If and only if the distance from the center of circle C to the center of the circle S is equal to the radius of the circle C plus the radius of the circle S. Okay, we might start with the distance between their centers. So it's the distance from 7, 13 to negative 2, 1. Using the difference formula, the square root of the change in x there from 7 to negative 2 squared. Of course, I'm going to ignore the negative here. Really, it's just the difference between these two. So that's 9 squared plus the difference between the y's, 13 and 1, that's 12 squared, And that's going to be square root of 81 plus 144. A little bit of simple addition there. That's root 225, which is 15. Radius of, the next thing we're going to look at is the radius of C plus the radius of S. We've already established that the radius of C is 10 and the radius of S is 5, which is equal to 15. So again, let me just go over this. The big thing is that they will touch externally as long as this condition is satisfied. The distance between their centers is equal to the sum of their radii. The distance between their centers is 15. The sum of their radii is 15. Conclusion. Therefore, C and S touch externally. Simple as that. Okay, make sure you learn this by heart.